So today we'll be talking about we'll do introduction to this new class that we'll study, and and then also we will start using the tool, SSIS tool, and kind of try to understand what's going on. What are those? What is their relationship to each other? Why we need to use SSIS to build data warehouse? Is it the only thing we need and stuff like that? We can go from there. Okay, so let's define what SSIS is first. Let's define what data warehouse is. So you guys got a book. Uh, Last time I gave you, I think it was on Tuesday, you were supposed to read 2 chapters from the book. That book talks about data warehouse, building data warehouse, implementing data warehouse. Every company, if uh, if the size of the company, usually 50 people or more, if they have a sales, let's say a couple million dollar company is usually a very small, tiny company in the United States. But even those companies, they have some kind of BI in their company. It could be one person team, it could be several people team. So any in your city, if you see any company name that has their own office, like big separate building, 100%, not 99%, 100% they have BI team. They have a uh, they they implement data warehouse somehow. It could be really advanced the data warehouse. It could be very early stages of data warehouse. Very simple implementation. So um, uh, as a BI developer, you'll have you have really good opportunity to find job any city in the United States. And these days, we are getting a lot of demand and ask even from Europe, even from developed countries from Asia, almost everywhere. BI development is like getting very popular. Especially data warehouse is something the companies want to implement because data warehouse will help companies management to understand their business, to learn about their business, about their daily activities, weekly, monthly, quarterly, yearly, last 5 years, last 10 years, that type of reports. If we talk about analysis of business of any company, that means data warehouse. So that's just a very small, very general description that I gave. But if you study the book first 2 chapters, it has really good descriptions. If you just Google, open YouTube, say what is BI, what is what is data warehouse? Data warehouse is implementation of BI, like business intelligence kind of creates data warehouse. BI developers create data warehouse. So what is data warehouse? Is it some kind of new thing? No, data warehouse is basically it is another database. So today I gave you guys a. Let me show you the link. I sent on Telegram a link here. In this link, you need to go. Everybody, please pay attention to this. So you need to go to this link. Last time, what we did is we got OLTP, and the SS when we studied SQL, we worked with OLTP database, transactional database. We looked at products table, employee table, sales order header, sales details, and a lot of transactional tables, transactional data. Now we'll be working with the warehouse database. The same AdventureWorks project was basically this is a fake company that Microsoft kind of creates. It's basically online sales company that sells, I think, bikes or some stuff. So they had their own like a OLTP database. Now they built AdventureWorks data warehouse. So this is backup files. The file that you last time we downloaded and we saw how to do was from GitHub. GitHub is a data repository location. So think of it as a YouTube. YouTube is for videos. GitHub is for developers to store their scripts, databases, application software, whatever the IT world, if they have some kind of files, they can actually open an account and they can share, save it here and share that with world. It's usually free. So the last time you downloaded MDF files and you went here, and right here you had options for OLTP, like you have a MDF file, backup file, and you have the script. Same thing you can find the data warehouse too. If you want to do it this way, like you learned last time, you can do the same thing. But I want you to try a different way today because you want to be able to see everything in the usually in the company. If somebody shares a database with you, usually they give you a .back file, backup of it. So we will learn how to do it. So what you need to do is you're gonna select AdventureWorks 2012, download it, go to your data local disk, go to C drive. In your C drive, you will go to program files. And in the program files, you find the SQL Server folder. There's Microsoft SQL Server right here, and find the right version. Probably you have just one version. I have a couple, several versions here. So this is the server that the 2012 version that I downloaded, installed for this class, especially for using data tools. So you just go to this file, and here you have, last time you put the databases MDF file, main data file, MDF file in here. So this is where your MDF file lives, also plus LDF log files as well. Like when you first create MDF and you start working on this database, log file will be auto-generated. Every transaction you do, especially update, select, delete, will be writing in this log file. So this is what we did last time, but this time you have to go to backup. When you open backup, if you do it first time, it may ask you to, like, you don't have authorization, whatever. You say, okay, just confirm, go and paste it here. You see, I pasted it here. As soon as you paste it there, so what you need to do is, so you need to go to your databases, right click, and here, last time we did attach. We attached the MDF file. If you remember, we did add, and from add, as you see here, it was getting the stuff from a data file because that was MDF. And you see the MDF, all the MDFs can be seen from here. But this time you are not bringing MDF. You're doing backup version of the database. So what you need to do is right click and restore database, because backup is basically you are restoring from a backup. That backup was taken at certain point of time, and that point of time version of the database you're restoring it. So you just restore, and after you select that, this window will come up. And so you should get the restore from a device, meaning from your local device, from your computer. As soon as you press this three-dot button, you will get this window, and then you say add. After add, as you see, it will open the backup folder where you dropped it. So you say this, and you say, okay, I'm not gonna do that because I already did that. So it's gonna just go successfully. So you say, okay, that's gonna be very easy process. So you need to do that to implement, to bring the AdventureWorks data warehouse. That's what we will be learning in this class, in this data warehouse. Is a little bit different. That's the goal for us to build We already have built AdventureWorks. We have looked at different transactional tables based on that data, and also the rest of the data that you can find for your company. It can be anywhere from anywhere. So you use all that data to build this data warehouse, AdventureWorks data warehouse. All right. So this is where we are right now. What is data warehouse? It's basically another database. It's just a database. Like OLTP database that we use, this is also database. It uses the same engine. It's not gonna the workers behind who were working for this, working for the same thing. It's absolutely the same stuff behind the architect, the engine that's working on this database. It's absolutely same thing, but data warehouse is a different structure than OLTP database. It's a different structure. Its structure is different. It's optimized for BI, business intelligence. To do BI, you have to create data warehouse because data warehouse will be faster. It will allow you to store a lot of data, and it will allow you to retrieve, to build reports from the data warehouse in a faster fashion. It's gonna be, it's the best structure that's available for BI. So basically, the point of this introduction point here is data warehouse is just a data structure, nothing else. It's, you are storing data in a different structure, and that structure is better for BI. That's why you're doing this. The other structure that we saw for OLTP database, the other database that we were working on, that's good for transactional purposes. That's good for company to do their daily jobs. Let's say if it's a bank, it's that database is good for bank users to log into their bank account and do deposit and withdraw money, transfer money, and check their balances and do a lot of banking related transactions. That was good for that purpose. If it's Amazon, that database was really good for controlling the sales of their online sales. Like people log in and they search for certain items and then they buy them or return or leave reviews. Whatever they do, that those are daily transactions. It's basically a work. A company does a work, and OLTP database will help to do that work. But data warehouse is not designed for that purpose. It does not help you to do your work. Data warehouse is not used for doing daily transactions, and it's not used for by your employees at all, by your users, by your customers. They're not gonna use, when they use application is not communicating with data warehouse. Data warehouse will live somewhere else. It's basically another database and in a different structure, and that will help managers of the company to look at the reports and make decisions based on those reports. They look at the, let's say, the company uses some kind of reporting tool. It could be just Excel sheet, Excel spreadsheet, and they may see the list of the sales, list of the items. For example, Amazon will look top 500 items that are sold in last year. And then that could be a report, and it may have some matrices, matrix information, meaning like a number of sales, the most popular like a season, what season was more the peak for these items, and what are the most popular colors, sizes, and modifications, and what regions of United States buys these items more. That kind of, analytics, business intelligence, that's what it's called. So data warehouse is built for that purpose, to do business intelligence. It's built for company managers. It's just basically same database with different structure. So data warehouse is a source for reporting, analysis services, and data mining. So reporting, company managers, CEOs, whoever manage the process, they need a report, because anyone sitting, for example, CVS, They have a couple thousand locations, and how headquarters of CVS can manage those different locations, and every location have thousands of employees, and they are doing something at this moment. How they can process, how can manage those people by looking at the reports. The reports, they can build any report they want to know how every location is doing, how managers at the locations are doing. Are they doing good job, bad job? Are they failing somewhere, making any errors? Are they losing money somewhere? Someone stealing something, breaking something? This report will tell, and data warehouse is a source for that report. Analysis services. It's completely, it's part of the process of BI development. I will talk about it at the end of the class. It's basically you build cubes. Cubes is when we studied group by, it had a cube extension. And you guys, if you guys remember, let's say if you in the group by clause, you use cube with several columns, 2 column, 3 column. Cube will give you every combination of group bys for those columns. So SSAS will do that job because group by is very expensive operation, very hard operation systems. It overloads the system. Uh, that's why Microsoft had to build new tool just doing that on a certain schedule. For example, it may group by 7 millions of rows only in a couple of hours, so that the CEO or regional vice presidents or managers or some higher level senior management will look at the sales, not so they can look at the sales by city, by region, by country, by state, by manager, by product, by whatever they want to drill through and see different categories and see like a total amounts, aggregated amounts. This is what it creates, analysis services. This is analysis services. It's called SSAS, the jobs at the market. Probably if you become SSAS developer, probably like 1% of the whole BI development, maybe like 5%, which will also include it. You will have to do something else. This is not as popular as being a report developer, database developer. SSIS developers are the best ones. 10 more times you can get jobs than compared to analysis services. Anyone that does SSIS reporting T-SQL, they can be trained like 2-3 days and they can start SSIS too. So that's why we're not going to focus on this a lot. Learn and waste your time and your energy, your memory is limited. So we're not going to waste too much time on this. This is what it is. So that also, SSIS also will use data warehouse, not the OLTP database, but uses data warehouse. Data mining is another thing. Data mining can be, you can, while you're working as a BI developer, you may hear the word data mining. Like, let's say your manager may say, hey, can you do some data mining and figure out how to calculate this logic? That data mining is completely different than this one. There's actually an area of expertise that's called data mining. Usually, people with a statistics background, like business analyst, data analyst, like they usually do some statistical tools to do data mining, and they do some kind of regression analysis, blah blah. That's also outside the scope of this BI course and also your profession. You're not gonna do this. You're not gonna get job interview questions on this at all. But that's third user of data warehouse. That's why I had to list this. As a report developer, as a data warehouse developer, ETL developer, SSIS developer, you will be creating and working with data warehouse. What is data warehouse? It's not as it doesn't get the data usually from one place. Usually, it combines data from multiple data sources. It can be RDBMS, means basically SQL Server, Oracle Server, MySQL, IBM's DB2, or SQLite, for example, whatever the relational databases. Or it can be ERP systems. ERP systems, so the ERP system is basically any company that these days they're using ERP. ERP is enterprise resource planning. This kind of integrates every company's all departments data. Let's say every company have a HR department, finance department, accounting department, and all of them should probably, for example, work with like a list of the employee names and their information. They usually store that stuff in ERP. ERP kind of centralized source of truth, and it kind of integrates all systems. Let's say HR department has to be able to exchange information from finance department, and they may be using different tools to manage their department's work. ERP will help them to kind of exchange information, to be in sync, stuff like that. So why I am talking about ERP? Doing SSIS class, you're not going to be working with ERP at all. We're not going to pay attention, waste time on that. It's just when you start working, if they talk about ERP, don't be confused. Don't it's just the work specific stuff. Any bigger companies you work, usually they have some kind of ERP systems like NetSuite, JD Edwards. Oracle is champion of ERP systems. Even Microsoft, Amazon is not able to compete with Oracle. They have two most the top most popular ERP systems. Probably you will see some of those. When you start working, you will see them. CRM is same like a very small version of ERP. Basically, the CRM customer relationship management, some kind of tool. It can be Salesforce.com. It can be many other tools. But basically, what it does is, especially, for example, you sell stuff online, and you sell stuff to thousands of people every day. After 5 years, for example, if you don't use CRM, you will be so upset because you have sold to 10 or 50 or 100,000. You had 100,000 customers, but you have lost them. You don't have them. CRM will help you to keep every people that contacted with you, bought something from you. Every customer that you had will help you to build a profile for them, and then you can actually work with them directly. Let's say if it's their whole birthday, you can send some kind of a discount vouchers, and you can actually, if it's a women's holiday, you can send them like some kind of a just warm emails congratulating and telling that you have this sales, blah blah blah. Yeah, it's a completely different tool, but also data warehouse also gets data from CRM as well. It may. Excel spreadsheets, still a lot of companies use Excel spreadsheets. You will be surprised. Flat files, it can be, for example, a lot of applications, they throw data, they generate data on some folders. Let's say daily, they may do some kind of, let's say you have some kind of tool, scanning tool, and you're working in a, let's say, store, and you scan and stuff, items, count them and do your work. And at the end of the day, when you bring the scanner and you just put it in in its hub, so it will download the file into certain folder. And an SSIS ETL tool that we will learn will grab that file and bring it to data warehouse. Basically, data warehouse will gather data from everywhere. It can do everything. Uh, Depending on the company you work, your sources might be different. Usually, the most common ones, if I tell you, it's going to be flat files, spreadsheets, and some kind of databases. SQL Server, Oracle, something like that. 90% chance, I would say even more than that, it's going to be those, the ones that you will do. ERP, CRM data, they usually store, they load that data to some kind of a SQL Server or Oracle or some kind of a cloud server, and then they tell you to do SSIS work, ETL work to grab that data from them. ETL. ETL is very important component of data warehouse. ETL jobs, ETL processes bring data to data warehouse. While they are bringing data, they usually clean the data as well, because it's possible that data might be missing. It could have a lot of nulls, duplicate values, and it's possible that some there could be some problems with the data. So ETL job, when you create your package, you have to clean that data, and business analysts and architects and team leads will give you the requirements, will give you the requirements document, and it will tell you exactly what kind of cleaning you have to do. You don't have to figure out by yourself. And also it would standardize the data, the ETL that you will create. What it means is, for example, you may have a companies working like you may have a locations that, for example, us we have like 500 clients that's all around the world. Europe, Asia, like South America, they speak in different languages. Their monetary systems are different. They measure size and weight of stuff in different languages, in different uh, like whatever measures they have. So when you build a data warehouse, when you bring the data from different places, you have to standardize that data. It has to be, everything should be in one measure unit. It should be, if Americans use pound, but if you're building a report for Europe, you have to convert everything to kilograms, let's say. So you have to standardize the data. So everything should be in one consistent, clean format. Usually data warehouse data is very clean, readable data. That's for management. It does not have a lot of like metadata, a lot of unclean, unstructured, like unclean data, raw data. It doesn't have it. Like usually it's in a more business user friendly format. Data warehouse is optimized for reading data, but not for transactions. Yes, it's basically it's designed for reading, means report, creating, generating a report, select statement, reports. Not for transactions, meaning inserting data and updating data, deleting data. It's not good for that. It's basically, it's just for writing a select statements in a data warehouse. Because you can actually absolutely do the update, delete, inserts. Yes, you can do that. But this for that, because this structure of the data warehouse is a little bit different. It has redundancy problem, so it's going to be harder to do updates, and also it will have a very huge amount of the data. You don't want to like when you want to OLTP is designed so that you create an application, it sources data from the database, and the database is used, let's say, from 1,000, 2,000, 5,000 people. They're doing some kind of transaction using your application. And that application is communicating with the database, OLTP database. And in every transaction they do, they insert something, delete something, update something, they do some kind of process. That is, if you do that on top of data warehouse, that application will be so slow that not 5,000 people cannot use that application. It will be frozen. All production work will stop working. That's why people don't use data warehouse, of course, for that purpose. For that purpose, they use a transactional database, OLTP type of a database. And also another benefit of a data warehouse, it can store historical data. Historical data, you may hear that term while you're working in a company. People misuse this term by saying that all the data generated since the beginning, like history of this table. That's not what it means. Historical data will learn what it is. There are slowly changing dimensions, and you have to handle them. For example, let's say uh, employee changes location. Let's say you have a salesperson, and the salesperson changes its sales region from one place to, like, let's say he used to live in New York, now he lives in LA, Los Angeles. So he starts selling stuff. OLTP database, you don't care about where he lived before. You just change their address to the new one. But in data warehouse, it matters a lot, because what you do is usually you create a report and see every you generate total sales by location, for example. Let's say, this year I'm selling, my top sales are in New York or in LA. But when the salesperson changes their location to LA and they, let's say they worked 7 months in this year in different location, now they moved to this location. At the end of the year, you may account their sales in New York as if it happened in LA. And that's bad report, and that will inconsistent data that will break your report. So you have to be able to calculate 7 months of work differently, 5 months of work differently, in order to do that kind of like a slowly changing dimensions affecting your report. In order to handle that, you have to be able to your database have to be able to track historical data. Data warehouse is created for that. It has the benefit for that. And that's what we'll learn in the coming classes, how to do that and what are the certain aspects of it and how ETL package can be created to handle those scenarios, stuff like that. All right. This is a very popular interview question. Like when they start asking you about questions about data warehouse, they will definitely ask you about difference between OLTP and versus OLAP. OLTP versus OLAP is very confusing question. Theoretically, by the book definition, OLAP is not data warehouse. OLAP is a cube. SSAS, the one that I was talking earlier, creates OLAPs, cubes, technically by book's definition, but on a like a day-to-day basis, people refer OLAP as if they are talking about data warehouse. So you have to, like when you hear OLAP, when you say OLAP, usually you just talk about data warehouses. So they ask what are the main differences of OLTP and OLAP, and you have to be able to talk all about these differences. There are a lot of differences, and in this table I try to point out the most important ones. Different categories by data structure, by data's origin, the quality of the data, size of the data, retention periods for the data, the standard, the users of the data, indexing, and other. All these categories and their differences. Let's talk about the first one. When you for interview, you have to just memorize it like by memory. You have to be able to just talk about it. There are like at least 10 differences here. If you just talk about this is more than enough. Even you talk half of about this, this will be really good information. Let's actually see what it means. First of all, structure. Data structure in OLTP, we talked about it. It's in third normal form. And why it's used in third normal form? Because it's really good structure for inserting data, updating data, deleting data. Insert will be super fast. To update this form will help you to update only small set of data, and that data will apply to whole database. It's just because your data is not redundant. There's no redundancy in the third normal form. That's why your updates, your deletes, and your insert will be affect to a very small subset of a data files in your database, and you will make the change. That's why this comments will be super fast. But for selects, even this one is really good for selects too, because when database, OLTP databases in, let's say, transactional system application, when it does select, it selects very small subset of data. Usually, OLTP usually has a smaller table, smaller amount of data, and also usually when application software, when it selects in order to, let's say, update, it has to select something, right? Or also to show, let's say, inventory balance on the screen of your device, you have to be able to select it. But those select statements usually are very small. They don't require a lot of joins. They just touch only like today's set of data or some certain uh, products. Like you just write a very small select statements. There will be super fast select statements. But data warehouse is designed to work with complex select statements that require a lot of joins with big amounts of data, with large, humongous tables that have several hundred millions of rows, maybe like 10, 15, 20 millions if they're kind of small database. They have to be able to join with each other and do a lot of uh, complex scenarios. So for that purpose, in order to reduce the number of joins, usually second normal form is used for data warehouse. There are some scenarios that tables, for example, fact tables can be considered as third normal form, but most of the tables, especially the measure, the dimension tables of the data warehouse, they are in a second normal form. Let me give you an example what I mean. Really good example here. If we go to our old data warehouse that we used to look, and there is a really good view. Where is it? For example, employee view, right? Select top 1,000. We just are. So it has 290 rows, and copy that, paste it, and we will look at the table now. View versus table. So this view, the top one is the view. The top one is the type of the data that you would see. This top is the type of the data you will see in a data warehouse. So in a table, you will see employee name, first name, last name, their address, their phone number, all the information about employee in one table, in a dimension table usually, but don't pay attention, like don't focus on what is dimension in fact. That's going to be a focus of another class. But basically, another like one table in data warehouse will seem kind of will be looking something like this. But on OLTP, employee table, for example, does not have their name, does not have their address, does not have their phone number. It doesn't have much information. To get that information, you have to go to different table and join them. Let's actually look at the definition of this view. So if you go to this view, right click and script view in a new window, in order to derive this nice clean structure, we had to write this many joins. Joins are very expensive operations. Joins are bad, especially when we are joining whole table. There's not even a where clause here. We are joining when you don't have a where clause. Even uh, indexes will be like not much helpful. On clauses, yes, but it's like a lot of stuff. It's not gonna be very super helpful. At the same time, you just to derive all that information, you had to join to person table, address table, from address table, even address information is located into so many different tables in a country table, in a like a email address is another table, right? So this is expensive. In a data warehouse, in a OLTP, these tables are very small, 300-400 address table. But in data warehouse, they are usually huge, humongous. They are millions of rows. But not for measures. Probably they will have less rows. but it could be possible that it's collecting data from different databases as well. This is just this one AdventureWorks 2012 we're looking at. It's possible that data warehouse is getting products about their different locations, different offices. So their employee table will be larger, huge, and in order to generate this, you don't want to do this join statement all the time. What you want to do is you want to store all the information in this form. In here, you want to store in this form. So next time when you want to see this data, you just do select stuff from one table instead of this view, crazy view that joins to so many tables. Joins are very expensive. The benefit of the data warehouse is going to be not using joins. Join is very bad. So second normal form will help you to avoid those joins. If you see this address is like a city's state is coming from somewhere else, but you see Washington is coming so many times in this database. In OLTP, usually you just put for this column, this, all those columns. All these columns, this to this site, you don't have to put it in one table. All you need to do is to cover all these columns. What you need to do is just create one column, and for this row, you will give just address ID, and then you create another address table, and then in that address you will put the addresses, and then you just will have one column for that. So that's going to be easier for this database. This database has a lot of, that's why IDs, a lot of metadata type of the information, like a lot of fake keys, surrogate keys, also another key. Like this database has a lot of keys, and that, but the benefit is, let's say if you need, you wrote Washington wrong somewhere. If you are in OLTP, you just come here in one state table and you change from one place, one row, you change Washington. But if you had to do the same thing in a data warehouse, you would have to find all the Washingtons and make sure you wrote correctly for all of them, because Washington is returned so many million times here. In OLTP, it will be returned only one time in one place. The rest of the places, it would be referred to as a key. So you know what I'm talking about, right? The benefits of third normal form and second normal. You can study yourself about their difference. Origin, where the data comes from to this database. So where data comes to this database versus to this database, where the data is coming from. Transactional database usually inserted by your end users. Your end users can be your employees, your customers, your vendors, your clients, whoever uses your tool, your application, any process that you use, they use those tools, and those tools behind the scene writes into database. But in a data warehouse, tools does not write into data warehouse. You create ETL jobs to migrate those generated data from different systems. You migrate those data. That's what happens. And the quality of the data. Transactional data is usually raw data. It's not clean data, because when we looked at this table, for example, data warehouse, that's why. What table I was looking at? Employee. This data, if you show it to management, they have no idea what it is. They don't want to see this. Like this. They like this, for example. You don't want to show this to end user, to your management. you want to show them data in a more meaningful format, and you want to get rid of those type of the raw data. You will usually use your ETL to kind of give some meaning, like remove those extra stuff and show only the data that makes sense to them. Expose, so you don't expose everything from this database. Probably you'd expose like like more than half of it, of the data, but 30-40% of this data is useless for management. They don't want to see the different keys, different hash bytes, different GUID values. They don't understand that. Looking at that, they cannot make business decisions based on them. You want to retrieve only good information. So transactional database has raw data, but data warehouse has clean, standardized data that management can look and make business decisions among them. Sizes, transaction systems, usually they are a couple gigabytes of data. And then if it exceeds, after certain period of data, all data is not used by transactions. Usually companies archive that data. They get rid of it. They just don't delete it. They just put it on some kind of archival databases. Also, that data is moved to in data warehouse, and data warehouse will keep, if a data warehouse keeps as much data as it can, the data warehouse will become as better as it is. More data is really good for data warehouse because better decisions can be made. Less data is better for transactional data. Usually they are in gigabytes. This is in terabytes in sizes. Retention period. Every database have usually retention period. Like that can be a really good question by you when you start working in a company. Let's say you want to ask something about database. You may ask, what is the retention policy we have on this database? Usually, at least it will be 3 months. They keep the data for 3 months. After 3 months, they put it in some kind of archival database. Some of them can be up to 1 year. If the process is not organized really good, it can be a couple years. Long term is for data warehouse. Minimally, you want to study the data for last 3 years or 5 years. For last 10 years, you may not care because market is changing, customers are changing. Now there's more demand. So maybe you're not that much interested to know what you were doing 10 years before. But last 3 years, at least, is analyzed using data warehouse. Users, like I said, thousands of users, employees, workers, everyone, even your managers can use this one, but they use it as a user to log into system and do some kind of work transaction. But this is for reporting purposes, for analysis purposes, BI purposes, usually for management to make decisions. Indexing, minimal indexing is recommended here. Primary keys should be enough most of the times. You need primary key for a table because you want the data to be ordered. You want to be the data to be retrieved faster. The primary key will create clustered index. That will be good enough. But sometimes you will have to also create non-clustered index. I would suggest maybe in total 5 or 6 indexes overall in one table in transaction systems. If that table is very popular, if it's joined to many other tables, then you have to create non-clustered. But data warehouse, it's designed for reading, so high indexing will improve the speed of your reports. That's why it's recommended to create a lot of reports. Also, there is a certain type of the index that's used for data warehouse. It's column store indexes, very popular. That's used. Indexing is really good because this database is not used by thousands of people. It's just used by most of the time by ETLs, by reporting servers, for example, reports for get the data from it and then deliver it to management. Management is not going to come directly to data warehouse and write their queries. They don't do it. They don't know how to write query, or they usually receive the reports in some kind of dashboards, or a report may be emailed to them. So some kind of report builder will query this database, So not a lot of traffic here. So your query, for example, may take 3 hours to run. Who cares? No one cares, because after 3 hours, the result will be out and it will be available in the report, and then the report will be sent. But here you cannot write queries that takes 3 hours. Usually it should be seconds, 2 seconds, 1 second, a couple seconds. Queries should be fast because people doing work, doing some kind of operation. So different type of structures, right? There are other differences. OLTP reporting from OLTP is not recommended because report will kind of slow down your system. If people doing their work, if you hit OLTP database with your reporting server, it's not allowed. You shouldn't do that. You should create some kind of data warehouse. At least I know some companies, what they do is they do reading replica of OLTP database. Let's say this, they create a copy of it, and I told you guys to read about uh, highly availability technologies, HA technologies for OLTP system, OLTP databases. If you remember, where is it? Here, right. We can do that. SQL Server HA technologies and SQL Server technologies right here. For example, you can have a look at here. There's a replication, log shipping, mirroring. At least know their names. That could be. This is DBA's job. It's not going to be your job to do, but you have to understand the concepts, what they are, or at least be able to tell what the names are. And you may say, I know what they are, what they do. I've never done it myself. I can understand the process. If I have to, I can do it. So do that, guys. SQL Server technologies. So using these 5 technologies, you can do replication, log shipping, mirroring, clustering, always on availability groups. You can create any of them so that you will create another copy of it. It's like a replica of it, and it will be in sync with this. And then from that replica, you build your report. Your purpose is you don't want to touch this database for your report because this database is being used by the application, people using to do their job, and you don't want to interrupt them. You don't want to load that system with your reports. So you create copy, and then then you create a report on that. Smaller companies, inexperienced companies, the companies that don't want to invest money into BI, into data warehouse, they do that system too. So that's why sometimes the company that you're applying for a job, they may ask about those technologies because maybe that's what they are doing. Doesn't mean they're not going to pay you really good salary. BI developers get same salary that they would get in a big company, even they work in a small company. It doesn't matter. Usually, if you work in smaller companies, you don't do much work. Your work will be very easy. You get lazy. The bad thing about it is you stop learning, you stop improving your skills. That's the bad side of it. Good side is you don't do any work. You just go there and you just do small, easy stuff. Every once a month you do something, but the rest of the time you just enjoying, you drinking coffee and talking with your coworkers and enjoying your life. That's it. I know a lot of guys that does that. BI, like a BI, they're BI developers. They got the job through this program, and they got the smaller companies. They don't have really good data warehouse systems. They're enjoying their life. They don't do nothing. Just they sometimes they work like 2 days from work home. That means that they just sleep. They don't log into their laptop at all. They enjoy their life. But the bad thing about this is technology is evolving so fast. After 5 years, if you don't continuously work on difficult projects, after 5 years they will become weak BI developers. For them it's going to be harder to find jobs. But if you work for a company that does really advanced data warehouse systems, you continuously learn, you stay on top of your system, you can actually become team lead or manager or stuff like that. So reporting is not recommended on top of OLTP databases. It's data warehouse is optimal for reporting. You have to build that. But companies that are lazy or they don't want to invest in creating data warehouse, they use some kind of HA technology to create the copy of this database, and then they build the report on that on top of that. That's what I was talking. Historical data we'll learn how to do it. This is a concept. AR modeling and dimensional modeling. Two types of modeling required for this database. OLTP, OLAP. For OLTP, this is ER modeling, right? Entity relationship. It's if you look at the model of it, it's complicated. It's difficult to look at, to maintain, but it will do the job really good. It will make sure the system OLTP is super fast and super responsive and solid. And this ER modeling will help the database to remove the data redundancy and to improve data consistency. Two aspects, qualities of the OLTP system, right? So if you go here, if you go to database diagrams, guys, if you cannot open the database diagrams, I suggest you go to properties, and then in the properties, maybe you don't have in the files, you don't have this owner permission. So what you need to do is press on that button right here, and it will do here. And what you need to do is you have to do SA and check and say okay. So that way you will have a permission to look at the database diagrams. In this case, this database does not have a diagram. I'm going to create the diagram. If you don't know, let's go there. Right here, new database diagram. And then what I will do is I'm going to create everything here and say add. It's going to be very expensive. Like you see, it's absolutely terrible to build a diagram. If you guys look in the internet, there are a lot of nice and clean diagrams that people have created and shared. You can look into that as well. But in this case, you can actually using this database diagram tool, you can do the same, achieve the same thing. So let's say close, and then as you see, it has here as your diagram. If you right click there, and then zoom to fit. So you see how ugly this is, how complex this is. OLTP structure, ER modeling is difficult. Database designers, architects, they built, but this is very efficient way of building databases, right? So if you look at data warehouse, it's completely different picture. Same thing. If you don't have access here, first you're not going to see these diagrams. You have to add access to it. Then it will open. So there are already built diagrams. We'll look at least one of them. For example, retail sales. Look at this diagram structure. Very easy to understand, easy to digest as well. So I'm going to do is I'm going to zoom it, and then we will start looking into this database. For example, it has dimensions, and right in the center, we have fact. We have some other dimensions. For example, here, this dimension, product. If you remember the product table in OLTP, it had a lot of keys, a lot of unnecessary stuff. But here, it's just the stuff that is coming here, the stuff that makes sense to management for the report. They're bringing only the required stuff. And we will learn how to build this structure. This is called, let me see, what is it? So this is basically a snowflake, but star schema is the most popular one that's used. This one, because everything should have connection with this guy in the center, fact. If dim tables, dimension tables should only have a relationship with this table. If they have a relationship with each other, they're called star schema. Snowflake schema. Otherwise, they're star. So we'll talk about what is star, what is schema, how to build them, how to maintain, and stuff like that. So the point that I'm showing is they're modeling, dimensional modeling. We just see you have to build a model, a structure that grabs data, only required data for reports that make sense to management when they look at it, and to improve their decision making skills. But you shouldn't grab unnecessary data. At the same time, you have to simplify your schemas. You have to break the data into different, I don't want to say this crappy design. You have to break it down into smaller pieces, smaller schemas. That's how they are called. To Snowflake star schemas. And every schema should answer to certain question. For example, this one should answer retail sales questions, and this one should talk about product inventory. So you kind of architect, database architect, data warehouse architect will come up with this solution they will give you, and you will create. And that's not the scope of our discussion for today, of course. And the last piece that I want to talk is this is a nice picture that there are millions of pictures available in online. This one I thought is very brief, a very easy explanation of whole BI structure, what the BI stands for. So in order to build BI, you have to collect data, you have to move the data, collect data from different databases, right? You have to integrate them and move them to some kind of storage, a big storage, data warehouse. They also divide it into data marts. That's the topic of another class. But basically, CRM, ERP, databases, files, APIs is another thing. You can get the data from APIs as well. So your data, your company's organizational data could be anywhere. And then SSIS tool that we will see today, learn today, will help to extract that data. Extract means to get this data from here, then transforms and cleans that data, standardizes the data, and loads the data to data warehouse. That's what it does, SSIS tool. That's the benefit of SSIS tool. And then when the data is stored, then we have to analyze it using reporting, creating dashboards, and then embedding means we put those analysis somewhere, in some application. It can be just an email, it can be a page, for example, on some kind of cloud server. It could be on a manager's phone. They may see some kind of like a page to see constantly checking the sales and income and revenue and the number of complaints, reviews, and so whatever the company specific stuff is. So this stuff, looking at that, they have to react to the data. Means data-driven decisions. The whole process costs a couple of millions of dollars to maintain and create. Everything is just for this purpose. All work that we do, write so many SQL codes and do ETL jobs and create reports, so that managers make good decisions, to improve decision making, to make data-driven decisions. That's what it is. Really good overall look at BI architecture, but if you just Google it, BI architecture, there are a lot of diagrams to help you to understand to the overall picture of BI, what BI does, what is BI, why it's needed, why I'm building data warehouse, why I'm using SSIS, because that whatever you're doing is just one step of this whole chain of events. That's what we're doing. And today, we did work on this part. Now we step on this part. In order to build this, we need to, this one is basically, give me one sec. Let me respond to this phone. I'll come back. All right, so sorry for the disruption. So database, if you a lot of you guys, I would say almost every one of you at this point is good candidate to become a database developer, SQL developer. This job, you may get this job, and you may create only OLTP databases or whatever related to OLTP. Or you may create, in order to create this, also you have to write SQL. So you may create the data warehouse objects and data warehouse developer, SQL data warehouse developer, something like that. But you may also become an SSIS developer, ETL developer, and you do this part. You may become just a report developer and you will do only this part. Or it's also possible that you do all of them as a BI developer, meaning you write SQL to create databases, you create SSIS packages, you create data warehouse implementation, and you create reports based on that data. All steps you may do that. Depends on the type of the job that you apply, and you may do some parts of it. So, and we'll see that in the future when we analyze the job descriptions at the end of this class. All right. So, all right. So when we come here, I gave you guys this link to download that data warehouse. So because we'll be looking some examples, seeing example, learning that data warehouse, because that data warehouse is already built, just to see how it should look. Also, I gave you guys this book. I want you guys to copy that book. Should be somewhere here on my last one. And this is the book that you need to study. This book is for you to study this ETL part, SSIS part. The last week, I gave you a book for this part, data warehouse, the structure. And at the beginning of this class, I gave you guys a book to creating this object. So you already had a book for this, and today's book is about this SSIS tool, about this process. So this is really good book. I chose this version this year for a good reason, because the newer versions are very confusing. They talks about a lot about new technologies, about cloud solutions and this and that. That is not important. This is the foundation. This is the most important part. And it has too much information. I don't expect you to read whole book for it. It's basically if I need something for my work, I can open this book and learn it. So it's basically professional guide. So it's good for a beginner, and it's good for anyone that's already working. So during your work, you can actually search and learn a lot of concept stuff while studying this class. If you have any question, just come to this book and search, and you'll understand theoretical aspect, why certain anything that you open in your SSIS, any tool that you don't understand, any variable you don't understand, any function you don't understand, everything is in this. I want you guys before tomorrow's class to look into one thing though. Let me show what is that. It was 169. I believe it was this. Yes, this. So in a SQL class, you saw a lot of data types, which were like varchar and varchar, date, time, and integers, stuff like that. You are not going to see the same type of the data in SSIS. SSIS calls data differently. It's just in different names. So while teaching class, I don't want you to focus on what was the data type. Instead of learning, understanding what is going on, you may get confused when I say DTSTR. It's basically a character data type. When I say, for example, DTI4, I'm talking about integer. That's it. So look into this before tomorrow's class to when you see during SSIS class, if you see any type of this data types, you know what data type we're talking about. So this is really good guide. But basically, this chapter, I believe this is 5 or 6. It's really good chapter for you to explain about expressions, variables, and stuff like that. You can actually look into this and learn a lot. Basically, this book can answer any question that you may have while studying, watching videos and learning. If you have any questions, please look at this guide. This is a really good guide. You can always Google, right? You can do the same thing as well. Okay, so now uh, let's uh, let's create our first ETL package and start SSIS. So for that, what you need to do is you need to go here, and right here you have to say data tools. And when you say data, it should already show, but based on what you have in your laptop, it may show so many things. But if you say data tool, it should show you SQL Server Data Tools, SSDT. That's what you need to open. So that's what I'm opening right now. A quick note though, let me note it here while I'm talking. So depending on a company that you work, I'm sure you're not going to be using SSDT separately like you're using SQL Server 2012. You will use SSDT for sure, but it will be a component of Visual Studio. So you will need to if you get a laptop, if it's not installed, you will need to install it yourself, but it's highly likely it's possible that it will be already installed. Otherwise, you will have to install Visual Studio. When you Visual Studio will have something like this. Let me open my Visual Studio here. Let me actually exit it out. So this is the Visual Studio that I have. So basically, you guys will probably use something like this, Visual Studio. It's an environment, it's a tool that you can. It's designed basically. It's designed to be used by any type of developer, anyone. C# developer, Java developer, application developer, software developer, web application developer, BI developer, SQL developer. So whatever the developer you are, Microsoft, especially if you're using Microsoft stuff, then probably you will use this. So for that, you have to go to Files, and New, and then you have to create a new project. And then right here, you will have a lot of options. C#, F#, R, Python, whatever you use. But you need to go to Business Intelligence, and you have to do the integration services, SSIS, integration service, ETL tool. Or if you're doing SSRS reporting, you do this. So same thing when you open. I'm going to close this now. We don't need that. So whatever you open in your SSDT, inside part will be absolutely same as this one, because this SSDT will be part of that. I'm sure today no one is using, but if you are using 2005 or 2008 versions, then you will probably use Beats. Just for you to know, because I'm sure no one is using at this point, but if somebody talks about Beats, don't think that they're talking about some kind of super advanced technology or something that you don't know. It's older version of SSDT that was even weaker and smaller and had some problems. SSDT is now it's getting better. The newer version, starting from 2012, they created the SSDT and they put it inside the 2012 SQL Server as well, and they call this SQL Server Business Intelligence package. And then after 2012, they're not putting it anymore. So after newer versions, 2015, 17, 19, you have to download SSDT separately and put it inside Visual Studio. That's why at the start of this class, I wanted you guys to download SQL Server 2012, which includes SSDT, SQL Server, everything is in it in one place. So you're not gonna do a lot of installation. So SSDT, that's where we are at right now. When you come to SSDT, you go to File and the New, and then you create a new project, because basically we will create a new project, and we call this project ETL class. ETL underscore class or something like that. And then as you see, there's a solution name and there's a project name. So in architecture of BI development, most of the time it's any development inside Microsoft environment, it starts with a solution. Solution is like a biggest package. That's how you can understand, like one group of things, like your SSIS is part package that you tool ETL package that we'll create today will be part of the solution. Solution, then inside the solution, there will be a package project. Project will have a lot of packages. Packages may be in your package, you may have 100 packages. Every package is one ETL. Like you may have 100 of them. Project, you may have 3 of them. In one project, you have 100 packages. Also, in your solution project that you're creating, it's possible that you may have a database project as well in the solution. You may also have reporting project. You may have an ETL project. All of them you put into one solution, and you create it. You call it as a BI solution or data warehouse solution. This solution will include all the development work we in our team we did. Database developer created a database project. I am ETL developer. I'm creating this ETL project. And there's another reporting developer. He will create a reporting project, and all of us will put in this solution in one place. That's just basically a grouping. So, okay, so we will create, and now there are, you see here we're seeing in this SSDT, we're just seeing business intelligence stuff. SQL Server project you can create, and you can create database objects. But analysis services is SSAS, reporting services is SSRS, that is our next class. In SSIS is what we'll learn for this class now, integration services, that's what you need to choose, and you say, okay. Okay, so you'll get something like this, right? And we have a solution explorer, and we have, we don't need this window. This one is good enough for us. So this is our SSIS, and it's possible that you might not have this open. You may will close this, and when you close this, so what you need to do is now you are in this project, which is your project is called ETL class. In our project, our goal is to create every class. We want to create one package. One package. Think of it as a one query, one stored procedure. So every class will create different project package. So with this package, we can rename it as class 1. As we did, same thing in SQL, right? Class 1. Make sure when you name it, don't remove the .dsx because this file will be unreadable by SSIS engine. So if you, let's say, if you come here and you just do like that, no dot, what happens is, yes, you see it's unreadable now. It's broken. It's in miscellaneous. So what we need to do is we need to do basically rename it with dot. That's it. We put yes. Okay, now it comes back again. So this is our basically a package. So when you go, you see, when you enter inside the package, you are seeing this toolbox. But if you exit out, you're not seeing this toolbox. This toolbox is not the toolbox that you use for SSIS. This toolbox is used by, because this is basically you are in a Visual Studio right now. It's also called Visual Studio on top. Look at this. So this toolbox is used by different, like let's say, C# developer tools, Python developer tools, JavaScript developer tools. So this toolbox is it's just a legacy of this Visual Studio. It's just a menu that you don't want to look at, you don't want to ignore. Don't care about that. It's something that you're not going to care. The toolbox that you want to use, it's when you open here, it will usually open. Let's see if it doesn't open, right? You just it's gone now. look here. There's no toolbox. You come here and you do a toolbox here, and it opens. And this the toolbox that is opening is not the toolbox that you're looking for. So the toolbox that you're looking for is usually right here. You have to click it on it, and right here you have to click its SSIS toolbox. SSIS toolbox. Why I'm focusing on toolbox so much? Because in SSIS you don't write codes. The beauty of SSIS is it's just created so that people don't this is toolbox. SSIS toolbox is used for creating codes, scripts using drag and drop, using drag and drop. Basically, this stuff, toolbox, whatever it contains, it's certain piece of code behind the scene. It's some kind of logic behind the scene. You just what you do is you just grab it, drop and drag it and drop it on here. And when you do this behind the scene, it will write a code. Usually it's written in this file that we're writing. If you remember in SQL class, we were writing T-SQL. In here, it will write so what it writes is XML file. It will write in XML language. So that language, you store this. Where did I store this package? Right, package here, properties. Let me start looking for it. Somewhere in documents, Visual Studio 17, or am I doing the 10 one? Then so Visual Studio. I should have, when I create a project, I should have looked at where I stored. It should be somewhere.
It was saying something like Python projects or something like that at the end of the file.
Yeah, you can actually looking at the properties, you can find the same thing as well. But we're not going to spend time for that. But basically, when you create a project, it files in that file folder, and then when you open that file, it's an XML language. You're not going to read it. No one is going to read it. It's not even important. We don't need to know it. As long as we know the location, that's important. That's all we need to know. The SSIS engine speaks in XML language. So it reads your package, it understands what you're trying to do, and it will translate that logic to the underlying, I think it will convert into C#, and it will write this, whatever the package in C# language, and it does the job that you're doing. So if you're a C# developer, you don't need SSIS. You can write a C# code to do all this work that SSIS can do. But the benefit of SSIS is, what it is you can hire any BI developer that doesn't know programming language. You can teach them SSIS very easily, like in 2-3 weeks, for 1 month. You can teach everything about SSIS. And they start doing ETL process, and they start doing this whole process that's moving data from here. You can hire 10%, 100%, 100 people easily, because they don't need C# knowledge. People who have a C# knowledge, they're not enough in the market. So this SSIS tool, with the help of this toolbox, with the help of drag and drop, it will help you to write a script for data integration, for migrating data. All right. So okay, so we opened the toolbox. From this toolbox, now let's talk about them. There are tools available in control flow. I open the data flow because data flow probably you will work 95%, 99% of the time. You will be working only this task most of the time. When you open it, when you double click on it, you will go to data flow tab. From control flow to data flow tab. Inside the task, you have completely different set of tasks, toolbox again. So this toolbox is, as its name says, it has sources, it has transformations, and it has destinations. So what it does is data flow does ETL, but control flow will do a lot of tasks. And if you see the tasks here, this is just some examples of them, and there are some here in common task as well. You are not going to use 99% of them. You will never use on your entire life. Depending on your job, if you're a DBA developer, you may use a lot of this stuff as well, but DBAs don't have to use SSIS to do their job, definitely. It's just this package will kind of help you to automate processes, but there are 100 million different ways of doing those things as well. And here, this is, you are in control flow panel. Control flow panel, we're gonna add annotation. Annotation basically is like putting a comment. Control flow is it's an interview question, very popular interview question. Control flow. What the question will be? What is control flow in SSIS? Very introduction question. You have to memorize it too. Control flow implements. That's how I usually answer this question. Implements workflow, logic, or a package. For this package, control flow will controls the flow of this package, controls the logic of this. What work it does, the workflow is controlled within this page. This is the main page, entrance page, introduction page. Here, how you control the logical, the workflow for your package, and it has like most important, it has three types of components, and those are tasks that you are seeing on the side. They are containers and precedence constraint. Three things. So control flow, it basically manages the logic of this package. For that, this package usually does some kind of task, and this is the task. Everything you do is some kind of task, and that task can be controlled with the help of containers and precedent constraints. So let's say there's this work and there's this work. So there's another thing that you don't see here. You have tasks under common. You're seeing tasks. Basically, you can go to here and other tasks, and you can right click and move into common and favorites, and you can do them as a select them. But basically, this two thing: execute SQL task, data flow task, and from containers. For loop container is not used a lot. Sequence containers used only sometimes. For each loop containers, if you use some kind of looping, that's what it's used. So you use that to, and containers will study in another class. It's just one separate class. You can use containers, or you can use this green thing. This thing is this is something called a precedent constraint. Basically, precedent constraint will control the flow of those tasks. So this task will start first, and then let's say this will if this task fails, go ahead and start this task. If this task succeeds, you can this is three options. Success, go to this one, and there's also completion. We will talk about this this logic of precedent constraints. We will definitely talk about that stuff. But today, don't worry about that. That's not the point of the class, right? Today we'll talk about data flow task. Data flow task is basically ETL. This is what it is. ETL is data flow task. The rest of the tasks are some other tasks. For example, these are common ones. Bulk insert task will write the bulk insert statement to the database. File system task will help you to create, will help you work with files, flat files, and stuff like that in different file folders. You can use C# using script task. You can do a lot of work, but they are not as common. Most of the time you use ETL, and you do some other tasks in here. Control flow pen. Data flow pen is the goal of the class today. We have only one data flow. So here, if you go to this drop down, you may see all the data flows that you create here. You drop another one, you go here, and then you can actually change between them, that kind of stuff. So we'll be working here. ETL, this is what it is. Data flow is basically ETL. It has E part, which is extract, the sources part, where you extract the data, and it has T part, which is transforms. You transform data in here while doing this logic. And there's a load, which is destination, where you load your data after you bring the data from, for example, from different places, and then you do some kind of join operation to do transformation, you load it somewhere. Everything happens in this pane. There are also some other panes that we will, as we go, we start using parameters. Basically, like a store procedure parameters, you can define parameter to put in some variable into your package, into this package. So let's say your package is right now is in the development environment, and then when it's done, and you have to copy this package and run this package in, let's say, testing environment. But in the testing environment, they may have some kind of different naming of the tables, different naming of folder passes, some passwords, and some connection strings, whatever. That you have to pass it in as a parameter. That's when we use it. Event handlers, the good thing, the benefit of SSIS is when your package fails, you can actually control it, what happens, like when error happens, before, post, pre-execute, post-execute will help you to do something before you execute something, after execute, stuff like that, and we'll talk about them as well. Package Explorer, it's basically whatever you created will be here at the executables. We already see ETL because what we created. ETL, sometimes your package will be so complex, you put so many things in it, and then you may lose it. You may not find it because it's somewhere in your package. You go here to look for it. It's not used a lot. The most important place is here, data flow. That's that's where you spend most of your time, And let's create something today as an example. So we were talking about this view. We're talking about this view. This view can be easily a table into data warehouse. Let's assume that we have some kind of database, for example, data warehouse. For creating a data warehouse, you have to create a database. How are you gonna do this? You say create database, because data warehouse is basically it's just another database. That's it. So we call it as a reporting data warehouse, something like this. Let's create it. So we want to, so what our goal is now for this package that we created, we want to extract data from this data warehouse OLTP system, and then bring it and load it into this new reporting data warehouse. And right now we don't have any table, nothing in it. So we'll grab this employee views data that's this view returning, and we will put it into this database. This is the goal of this package. So that's what we're trying to achieve. Come to this tab. So what we need to do is now we have to do three. We have to. Today we're not gonna do T. We're gonna do E and L. So basically, this part we're gonna remove. What we'll do with today, extract and then load. Both extract from where? From database. Load to where? From to database. So that's the information you need to know before building any package, right? So it's possible that you can getting data from VIP, from data file, some kind of files, some Excel spreadsheets. So before creating your package, you have to know the source of your data and the destination of the data. Source is database, right? So in order to get the data, to connect to database, to extract data from here and or to right here, you always start with number one thing. You have to start with connection, building connection string. So the first thing we have to build connection string. There are a lot of ways of doing it. You can come here, you can right click here, new connection, right? Or you can come here, you can do new connection here as well. You can do, or you can go here and it will give you source assistant, which will SQL Server, which will help you to build that connection. Destination, same thing. So what we're gonna do is we're gonna just right here. Let's come here. Connection. So right here, if you come at the sources, I want to talk about the sources before creating connections so that you understand what we're trying to do. The source for any database, you can use ODBC or OLADB if it's a database, RDBMS tool. ODBC is being depreciated. It's an old tool. It used to be, everyone used to use ODBC. Now OLADB is being created, like maintained by Microsoft. So try to use OLADB source instead of, so right here, you do this, and now we haven't created connection string separately yet. What we do is we will open it. Okay. Right here, it has three options. It's just SSIS is basically by reading, you can guide yourself. Like you want to get data from some source, you have to build a connection manager, build a connection. So right now we don't have any connection, right? So we have to create a new one, and this dialog will come. So let's say this, you see, I've already built some database connections, so it's showing me. So what I'm gonna do is I'm gonna delete them. So when you don't have it, you will not have any. So what you need to do, you have to do new. In the new, you have to write a server name. In your computer, you have just one server, SQL Server. That's why you can just put dot, or you can write this local. And you do that, it will find. But on my computer, I have so many servers installed. So for that purpose, in order to connect to the right one, to come here, I have to find the server name of this server. So what I need to do is I'm going to write select add server name. Add server name is a global variable system function that will give you the server name. Here you go. This is the server name. I copy this. Go back here. Write this. You put the server name. When you start working, the server name is given by DBAs for you. They will give you all this information. Okay. So I'm using Windows authentication because it's on my computer. If I had the username and login, I would put it here. Here now in the drop down, it's already connected there. If I look at here, I usually have to type in the database name, but if I don't know, I can do this, and it will give me the list of the database that's available. Already it's connected. AdventureWorks 2012, it's my source, where the data is located, database name. But I don't want to bring whole database, right? This is just basically a connection string. So I have to define the table name as well, but wait for it. Let's test it. Okay, test succeeded. That's good. And we'll add that connection. That's it. So now let's say, okay, so this is coming up, and this is our OLEDB connection for the source. Right here now, you have to access the data that you're trying to access. There are different access modes. Variables, just don't worry about them right now. It's possible you can pass in database, the table name as a variable as well, but don't worry about it right now, because we're not going to do that. Table or view, when you do table of view, it will give you the first tables, and then it will give you the views. We are trying to find the employee. There you go. You can actually preview. In the preview, it will show you the data. Usually this is, you see, 2 rows up to, it's top, it's writing a select top 200 statement, select statement. You're not going to see, if it's millions of rows, you're not going to see million rows. It will just, you will see 200 of them. But also you can actually write a query as well. You can write a query here. Let's say, what query I'm writing here to get that information. This query, right? Execute. This query and paste it here. Do the same thing. The good thing is when you type in your query here, you can parse it and say, oh, it's good, it parsed. But it doesn't mean that you wrote the correct query. If you, let's say, if you put 1111 here, and then it will show, yes, it's successfully parsed. Basically, it's checking your syntax only, but it's not executing it. But if you truly want to see if this is working, you have to preview data. Otherwise, if you put in something wrong, when you preview data, it will not show you. So this is how you want to check it. Database table name is already checked in, so you can actually just put the schema name and table name as well if you want. There you go. It still works. So this is another way, right? If you don't know how to write, actually you can write a store procedure and you can say execute the store procedure. You can do the same thing as well. It's also absolutely possible. You can browse, and if you have saved your script somewhere, you can open the script as well. That's another way. Or you can actually build a query. Building query, just right here, right click, and you add a table. From tables, there's functions, synonyms, and functions and views that you, functions are usually table valued functions. That's what it's looking for. Views, you have to somehow be able to find that view from out of so many views available. Sales, salesperson, human resources, where are you? CDE. Basically, let's look at the tables and let's do a shortcut. Let's say we want to do business person table, and then we also want to do business entity address, for example, right? We add 2 tables, so it automatically detects based on the foreign key, primary key relationship available at the database. Based on that, it will find the relationship, and you see it will write the join statement for you. That's also possible. People who use SSIS, they may be not good at SQL, so that also kind of helps them. But for you, you don't need to do that. In our case, table view is good enough, and we have the source. Okay, good. Connection manager, we built it. We selected the table. Look at the time. Okay, so we have good amount of time. All right, so and then you will check in the columns. You can select everything, or you can select only some stuff that you want, and you can actually rename the columns, like give them an alias. Like, you know, in T-SQL you say as and you write. That's what you need. Like, you can change the aliasing as well. You can select them. Error outputs, I don't want you to pay attention to that right now. I will learn about it. This is another component. But to grab the data, that's all you need to do. You don't need to waste time here, just to start. Just configuring the stuff is good enough. Okay. So here we go. We have created this. For now, we don't have the load part. The E part we have, T we don't need. We have to do the L part. Okay, so now we have to do the destination part, which is the load. For the destination, you have to search from the destinations. We don't need the T part. C as E part. D destination is the L part. Sorry. So there are also common ones for the destination. We have well, this is our transformations as I see mostly. But if same idea, if you let's say if you want to bring into common or favorites, you can do the same thing. If you when you start using it a lot. From destinations, you will use this a lot, and this a lot. The rest of the stuff you don't use a lot. Believe me, guys. It's yeah, some of them yes, but most of the time this and files and stuff like that. So OLEDB destination, we grab it, put it here. Whatever we did so far has not available input. Okay, we'll give it input later on. This is the different components of it, but it's trying to grab the put the data to already available source database, but we don't want to do that. We can create new from here, but let's not create there. Let's create from here. New connection. We want to create an OLEDB again because database. We do that, and then we have to create new. Again, we have to provide server name. My server name is this. Okay, but this time server name is same, but database is different. I'm not choosing AdventureWorks. I'm going to somewhere else. I'm going to reporting data warehouse. This is my destination. I say okay, and now I have two connection strings available in this package in this project right now. So I'm going to say okay, that. So, and I'm going to attach it here. So when I attach it here, I don't have any table in my destination. When I try to find the table that I want to write, oh, okay, so I'm grabbing wrong database. I have to write it into here. When I do this here, I don't have any table, no table to load my data. I have to go to here, open my database and write SQL statement to create a table. But in this case, in our example, there's another way. You can actually create new. When you say new, it will give you a SQL script. Do you like it? Because it will create this based on whatever the source of the table. Already when you did, you will say, okay. We say, okay. When we did this connection, it already read. Let's look at this. Right click, edit. If you go look metadata, this is the source. It's reading the source. This is the data types. It already read, understood what the names of the columns, all it needs. It already built the table for you. Now, I should have changed the name. It's just named by itself. It says OLEDB destination. Bad name. I should have changed it, but that's fine. The problem is it's already created. Yeah? Yes.
By the way, can I ask you a question?
Yes.
Like for example, this was an OLDB source, right?
Destination both we are doing just a database today. Yes.
Yes. For example, if our source file was a flat file, does that automatically calculates the varchar dimensions automatically too?
So when you pull in your flat file, you usually define the types, like you can change them. And that's what we will see in the coming classes. Today,
Okay, okay.
We are just building a very easy, naive, simple ETL package to see what the connection is, what ETL, all the stuff. So some of the class, what's up?
Can I understand this from what you said? Like, if the source is the database, it is gonna grab the column types correctly, right? We don't need to.
Even flat files, you can make it grab correctly. You can change it easily. Yes, in a database, metadata information is in the database. In a flat file, it just guesses itself based on the data. But in a database, there's a table definition. So it automatically takes from the table definition.
Okay, thanks, Adam.
No problem. And you can also change that. And that's what we'll see in the coming classes. But today, don't worry about that. So if you remember right here, columns are here. When it grabbed the columns, it also grabbed the metadata about those. And it's coming right here, and you can see it from here, from properties. Sorry. This is the properties of this data pass. Get it? And right here, metadata, that's coming. So basically, it created a table for us. We didn't run this yet, but it created a table and it already established the mappings. Mappings is very important in ETL. Mapping, you have to ask from someone if you don't know, because basically every ETL package has their own documentation. And in the documentation, they have to say where the data is coming from and at the source, and what should be the mapping at the destination. If destination have some table, what column should map to what column? You have to tell them. And there's a title, first name, last name, middle name, suffix, phone number, whatever, all this information. It's automatically doing that. If there's something, and also if their names are identical, it will assume they're the same stuff. But if they're different, you can actually modify that, and that's not important. Okay, so we grabbed it from here and we put into here, and there are some other aspects that we don't want to care about that right now. So everything is looking good for us. We can go ahead and execute. So while executing, as you guys see, autos, locals, watch is being generated right now. Locals and watch is, if you have parameter values, you can see them also onto the progress page. It will tell you about all the progress as well. Also in the output, you can open the output file. Output file will give you information about this package as well, usually. All right, so here, control flow. Last one. Let's see what happened. Here, OLEDB destination table is the one that created, and this is 290 rows it generated. But in this ETL package, when I run one more time, again, it's gonna do the same thing. Again, it's gonna insert the data to that location. It will show you 290 rows. But if you want to know exactly what is passing, you can do the same thing. You see, I said you have to press this stop debugging because it's in a debug mode right now. What I'm gonna do is I'm gonna stop it. Right here, right click it, edit. In the edit, there's a data viewer component. You can enable data viewer. That will help you to see what the data is passing through. Right now, it's this data viewer will show everything. Basically, you can select some of them. Maybe you want to see just the first name. Okay. Just the first name, let's say. Last name. Or you may want to see everything, right? So you select every column that's coming in from here to here. Now you can see, you see this magnifier symbol. That means the data viewer is on. So now in this, so you start the package. Before So here is my data viewer. It opened in the other screen. So data has not passed to the next script yet. So it's first showing you. Usually it will show you if you have millions of rows, it has some kind of buffer size limit. But basically you can see, you can expand this. And see what kind of data is coming. You can actually copy this and put it into Excel sheet and figure out what's happening. If there's an error, like you can actually see and inspect all the stuff of it. And as soon as you say detach, it will detach and it will let go, and the data has reached the destination. So that's the data viewer is really good for debugging, to understand what is data coming from this component of ETL package to this component. What is data passing from here to here? The pass will show you. So now you will disable it. You don't have to turn it on. Basically, this is so we ran it 3 times. It loaded data to 3 times. We can actually rewrite the logic to make it. So someone is asking, how come we didn't create new table ourselves? That's what we'll do in the coming class. But today, we just selected the component of the destination to show you. I just wanted to show you guys that it's also possible that you don't, if you haven't created, you just press this button. It will create a new table, and you can actually rename the table employee. And it will create it for you. Cannot be created. Incorrect. Okay, it should be right here like this. Okay, and you go here and refresh tables. Employee table is created. The problem with it is it's just a no keys, no constraint, nothing in it. It's just basically it will create a heap table, no indexes, nothing like that. This is what we did for today, but we usually what you do, you write SQL statement here, you come in and create, you define the table yourself and do more development work most of the time. But this is, like I said, this is just a dummy introduction ETL package. So let's turn it off. Here you go, stop debugging. And we're gonna close it and we're gonna save it. That was our first project. So everybody's homework now is you guys have to create a package yourself, and you have to right here, full pass is right here, guys. Copy. So you go to the properties right here. If you press this, it will open right here. This is the properties window. From this, I copied the address of it. I'm gonna put it here. Control V, and I go. Okay, so in here I put something extra. Documents, Visual Studio 2017. Okay, there you go, Visual Studio. Why I don't have it? Copy. Okay, so there, OneDrive, I'm saving documents, Python scripts, ETL class. Someone in the class was very detail oriented. I like that. I am not good at detail oriented stuff. So Python scripts is here, ETL class is here. So what you need to do is when you create your package ETL class, so put this, you can do this and add to archive like this, and then send me the archive. Okay, and I'll open and I'll see that you guys have created the ETL package. That will be the homework for today. If you guys don't have any questions, we'll see you tomorrow.
Excuse me.
Yes.
I was gonna ask. So the like synonym versions of like Informatica has the same thing, right? Like this type of.
Informatica is yes, yes.
Are they similar? Like if you know SSIS, for example, can you like do that one?
Absolutely. If you use any ETL, you can use other ETL in one day. Like all you need to know the different names for the same thing that you did here. You will learn the name in the other tool. Absolutely. Behind the scene, they all do the same stuff, same idea, same logic, same approach, same operations, same steps. Absolutely.
Thank you.
Whatever ETL tools like SSIS is good for you to learn whole ETL process.
Thanks. Thank you.
Adam, can I ask you a question, please?
Yes. Go ahead.
Because SSIS is visual.